Okay, so you like picture that you've got this problem, right?
Yeah.
And it's so hard, even the world's fastest supercomputer would need, like, more time than the entire universe has existed to solve it. And
Whoa.
then, bam, quantum computing swoops in and solves it in 5 minutes.
5 minutes?
5 minutes. It's wild, right? That's the kind of crazy potential we're talking about today.
It's kind of hard to wrap your head around.
Totally. So we're going to dive into all of this, like how it actually works, what it could mean for like medicine and materials, and even like the whole financial system. We're using this article, what the future holds for quantum computing and how it compares to AI.
It's a really fascinating piece.
Yeah, and by the end of this deep dive, you'll get like a way clearer picture of whether this is all just hype or the next big thing.
Yeah, and how it all stacks up against AI, which is already, making waves.
Okay, so first things first, what even is quantum computing?
Yeah, so it's not just about speed, right? It's like a whole new way of thinking about how computers work.
Okay, so not just faster, like fundamentally different.
Exactly. Like, imagine a regular computer bit is like a light switch, on or off, 1 or 0, right?
Right.
But a qubit, that's the quantum bit, it's like a dimmer switch.
A dimmer switch.
Yeah, it can be on or off or like anyone in between all at the same time.
Wait, so it can be a 1A and D, a 0 at the same time? My brain is like already glitching.
Yeah, and that's where things get really interesting and like kind of trippy, honestly.
So how does that even work?
Quantum mechanics, my friend. It's all about this concept called superposition. So think of a coin spinning in the air, right?
Okay, I'm picturing it.
Before it lands, it's both heads and tails at the same time, in a way.
Right, like it's both, but neither until it lands.
Exactly. And that's kind of like what's happening with the qubit in superposition. It's in multiple states at once.
Okay, that's wild.
And that's what gives quantum computers this insane power.
So it's like instead of going down one path at a time, they're checking out like all the paths in a maze simultaneously.
You got it. And that's where the speed comes in. A classical computer might take millions of years to crunch through a problem, but a quantum computer could do it in minutes.
Minutes.
Yeah, and the article mentions Google's Willow chip. They're claiming it did a calculation in under 5 minutes that would take the world's fastest supercomputer, like a ridiculously powerful machine, 10 septillion years.
10 septillion. Okay, so we're not talking about your average speed boost here.
Nope, this is like warping speed compared to a bicycle.
Yeah, okay, I'm starting to get it, but speed isn't everything, right?
Yeah.
Like, what can we actually do with this power? What problems can it solve?
The possibilities are huge. Like, imagine medicine. We could design drugs at the molecular level, totally personalized treatments based on your DNA.
Oh, wow, like custom-made cures.
Exactly. No more side effects, maybe even cures for diseases we thought were impossible to cure.
That's incredible. What about other fields?
Material science is another big one. We could create totally new materials with properties we haven't even dreamed of.
Like what kind of properties?
I mean, who knows? But imagine materials lighter and stronger than anything we have now, revolutionizing everything from, like, airplanes to buildings.
That's pretty mind-blowing. And the article mentioned finance, too.
Right. Imagine being able to, like, simulate entire financial markets with incredible accuracy. We could maybe predict or even prevent financial crises.
Okay, so we're talking potential solutions to some seriously huge problems. But the article also mentioned some challenges.
Oh yeah, there are definitely hurdles to overcome.
Like what?
One of the big ones is scaling up. These quantum computers are crazy sensitive. They have to be kept super cold, almost absolute zero.
So like colder than space.
Basically. And we need systems with millions of qubits for these world-changing calculations, so building and maintaining that is a massive engineering challenge.
That's like trying to build a skyscraper on, like a foundation of jelly, right?
Yeah.
You need a whole lot of stability.
That's a great way to put it. And then there's error correction. These qubits are so delicate, any tiny interference, like a temperature change or vibration, can mess up the calculations.
So like one little hiccup and the whole thing goes haywire.
Pretty much. It's a huge focus of research right now, developing ways to stabilize those qubits and make sure the calculations are reliable.
So it doesn't sound like we'll be carrying around quantum computers in our pockets anytime soon.
Probably not, but it's moving fast.
And how does all of this compare to AI? Like, that feels like it's already here, changing things every day.
It's true, they're on very different timelines, but here's the thing. They might not be competing, they might actually work together.
Really? So not rivals, but teammates.
Exactly. AI is awesome at things like pattern recognition, learning from data, making predictions, right?
Yeah.
Quantum computing is amazing at solving super complex calculations that are way beyond classical computers.
Okay, so they each have their strengths.
And imagine them combining forces, like quantum computers giving AI this massive processing power boost.
So like quantum computers could help AI handle even bigger, more complicated problems.
Yep. Think massive data sets, faster training for AI models, even helping AI algorithms become way more efficient and accurate.
So maybe no quantum robots taking over the world, but quantum-powered AI, that's a whole other story.
It's definitely a possibility and one with huge potential.
But like you said, we're still a ways off from widespread use of quantum computing.
Yeah, it could be years, maybe even decades. There's so much research and development needed.
So quantum might not be better than AI right now in terms of like immediate impact, but it's the potential to solve problems we can't even imagine yet that's so exciting.
Totally. It makes you wonder, like, what problem would you want to solve with a quantum computer if you had access to one?
That's a great question, and honestly, one I'm not sure I can even answer yet.
It's mind-blowing to think about, and for anyone listening who wants to learn more, there's tons of resources out there, scientific journals, online communities dedicated to this stuff.
Yeah, it's a fascinating rabbit hole to go down, for sure.
The future of quantum computing is full of unknowns, and that's what makes it so thrilling.
Absolutely. Who knows? Maybe one of our listeners will be the one to unlock its true potential and change the world.
That's the dream, isn't it?
Totally.
Yeah.